All right then, well, I think we're just about coming up to the time that I can legitimately start, so let's do that. Yeah, it's really nice to see you all here. Thank you for coming to this talk. It's always a pleasure to be here at NDC Oslo. It's definitely one of my favorite conferences. It's a special treat to see your happy, shiny faces all smiling down from the steeply inclined slopes. It's great. So what's going to have this be about then? So my name is Steve, and I work at Microsoft. I'm on the ASP.NET team, and I do a bunch of different things there. I spend about half of my time just working on the regular, traditional server-side parts of ASP.NET, but I also spend about half my time working on trying to make the platform as good as it can be for people building client-side applications. So whether you're doing stuff with Angular, React, Knockout, Vue, Aurelio, or whatever else it is that you like, hopefully we can make the framework as good as it can possibly be for you. Now, I think that will probably be relevant to a good proportion of you. You probably wouldn't be in this talk if you didn't think that was relevant for you, but I just want to get a quick sense. How many of you are already using some kind of single-page application framework in your day-to-day work? Oh, like vast majority. Okay, great. And I assume that you're using ASP.NET Core as well, otherwise you wouldn't be here, is that right? Hands up if you are. Or just ASP.NET in general? Yeah, that's like the other half of the people. Okay, good, that makes sense. All right, so I can understand why you're here then. So let's talk a little bit about that. I'll tell you about what the status is presently, and then we'll spend most of the talk going through some demos of some cool stuff that we've got to make your development lives better. Okay, so we've got ASP.NET Core developers, and when we talk to them, they basically always say to us, or at least about half of them, or in this room it's like 90-odd%, yeah, we're using your product, but we're also using these other client-side frameworks as well. And generally, people like them. People are generally positive about whichever one of these sorts of frameworks they have chosen to work with. But they also say to us, but you know, there's a lot of other stuff you have to know as well. It's not enough just to know the client-side framework, but there's other things you have to know. For example, you need to know about various different language options. You know, there's all these different versions of JavaScript going around now, ES 2016 and 2017. There's TypeScript, which, you know, adds a whole extra level of concept on top of normal JavaScript. So you need to know all that stuff. And then there are other concepts as well, like you need to know about different styling technologies, whether you're using Sass or Less or something else, which is going to compile to CSS. And then there's more. In order to actually do that compilation, you need some sort of build tool in order to build your client-side code. It's not enough just to have script tags and links to style sheets and stuff anymore. No, we have to make it more clever than that now. So we've got all these different build technologies. And most people are probably using Webpack by now. There may be some of you still using Grunt or Gulp. They're quite different. I'll be talking about Webpack in some detail in this talk, giving you some idea about how exactly it's different if you're not sure. But there's more than that as well. There are various different client-side architectures that are getting a lot of adoption now. And you may have never have even heard of some of these. I hadn't heard of MobX until fairly recently. And these are a whole other level of things to know about. And if you don't know about those, just don't worry about it. I'm not going to talk about it particularly in this talk. But you know, those things are there as well. And then finally, there's various different testing technologies. So when you think about what it takes to actually make a project with all this stuff, it's an enormous piece of work. Even just getting started, you could spend weeks trying to put together something that actually links all these things together in a working way. So what people tell us is, can you make that easier, please? And how can we actually improve on that? What can we do to make that easier for you? Well, a thing that we've been working on for a little while and will be rolling out in an even bigger way soon is providing a really clean, out-of-the-box experience for you if you're trying to build an application with these kinds of technologies. So we want to make a nice, pre-packaged environment that allows you to create new projects with all that stuff ready to go for you. And we've been shipping these things for a little while now. You might have seen that originally we shipped some project templates on Yeoman. And then about 6 months ago, we started moving these templates over to .NET New, which is the command line-based way of creating new ASP.NET projects. And I'm finally pleased to be able to say that we're going to roll this stuff into the core product as far as ASP.NET Core 2.0 is concerned. So with ASP.NET Core 2.0, if you're using Visual Studio, as soon as you go to File New Project, this stuff is just going to be right there and ready to go for you without having to install anything special. So that's good for a lot of people, but there will be some among you who say, well, that's nice, but I don't really want to use your project templates. I want to do some crazy advanced thing all on my own. And that's fine too. So for you people, we're making sure that all of the technologies that we're using to construct these fancy project templates are available in the form of packages. We've got .NET packages on NuGet, we've got NPM packages, JavaScript packages on NPM, and you can use those as part of your own projects, even if you're not using our templates, to do some fancy stuff. But what fancy stuff? Well, that's what this talk is about. So let me tell you what we're going to do in this talk. The idea is to split the time that we've got into 3 parts. And in the first part, we'll talk about building a single-page application with all these technologies. We'll have a strong focus on the project templates and the functionality that they make available to you out of the box. Then we'll move on, and we'll look at Webpack a little bit, because that's really central to a lot of the functionality that I'll be showing you. And although some of you may know Webpack well, a lot of you will probably not really know how it works internally and what it's actually doing and how you can configure it. And I want to make sure that it doesn't seem scary to you and that you can understand what it's actually doing and how you can use it to benefit yourselves and your projects. And then finally, we'll get really deep down into the underlying technologies, and we'll talk about some of the more advanced stuff you can do that's totally separate from these sort of standard project templates. Okay, so for the part of the talk where we'll look at building single-page applications, there's a bunch of different features that I want to show you. And probably the obvious place to start, well, would be with getting started. So we'll start by creating a new project with ASP.NET Core and Angular or React or that sort of thing. Now, like I just said, this is being rolled into the core product at the moment. So when you get the next version of ASP.NET Core, even if you get the next preview version of it, you'll find when you go to create a new project, if you're in Visual Studio, that you've got some useful new options that pop up there. So you can just choose that and you're off and away. If you're on ASP.NET Core 1.0, you do not have those options. And so you will need to go to the command line to do that. Or, of course, if you're working on Mac or Linux and you're not using Visual Studio, then you'll need to go to the command line as well. So let me show you how we can create these projects on the command line. So the first thing you need to do is you need to install the template packages if you're in .NET Core 1.1. If you're on 2.0, then they're already installed for you. But let's say you don't have them installed. So the way you can do that is you can say .NET New. Now, that's the way to create a new .NET project. But we can also install extra templates by passing this install flag to it. And then we can give it the name of the package we want to install. And in this case, I'm using Microsoft ASP.NET Core SPA templates. And then I've got this really bizarre thing on the end, : : star, which is this totally crazy syntax to mean get me the latest version of that template. Okay, so you would run that, and it will install the templates for you. And once you've done that, if you run .NET New again, you'll see there are some new options in the list. So that's just added these extra options. We've now got the option to create projects with Angular or Aurelia, Knockout React, React Redux, and Vue. So you can use any one of those. Let's have a go at using the Angular one. So I'll make a new directory called My Super App, and I'll go into that. And now I can run .NET New Angular. And that will set up a basic project template for us with a bunch of nice features in there. And so that's laid out a whole load of files. It's quite difficult to make sense of in the command prompt. So I'm going to switch over to Visual Studio at this point where it's a little bit easier to show you the project structure. Okay, so what's in there? Let's have a look. So if you are familiar with regular ASP.NET MVC coding, you will be familiar with a bunch of these things. So we've got the www directory, which is where you can serve static content from. We've got other familiar stuff like controllers and views, and we've got the program and startup files that you would get in a regular MVC application. The bit that's really different, though, is that we've also got this client app folder. And inside there, we've got loads of stuff to do with the Angular application. And I'll show you that in a second, but let's just start running this application so you can see what it looks like and what sort of a structure it creates for you. So that's going to start that application up. And when that comes up, we will see that it looks a bit different to a normal file new ASP.NET Core project because it's using this bootstrap-based layout, and it's designed more for sort of dashboard or control panel type scenarios. But of course, you can change it in any way you want. You can change the layout completely, the styling. You can take out Bootstrap completely, do whatever you want. But this is a useful starting point for most of the types of application that people would build with these technologies. So what is in here? Well, there's a few examples. Firstly, we've got routing set up. So you can do basic client-side navigation there. That's using the Angular router to change pages there. And we've got a couple of example components. There is this very simple counter example that just counts how many times you click the button. And then we've got this fetch data example that gives you a sample of how you can make a call to your API backend, get some data, and render it into the UI. But how does that look in terms of code? Well, let's have a look at an example. I'm going to open the counter example. You just saw me clicking that button. So here's the implementation for that. Firstly, notice that it's a TypeScript class. So all of these templates are built with TypeScript, which obviously has many benefits like giving you strong typing and such. And the way it works in this case is we import the Angular core library, or a particular bit of it that we need here. And then we're telling Angular that this TypeScript class should be understood as a component that it can render. And it's got a bit of behavior, like it's got this count value, which starts off as 0, and it increments when we call this method. And we're associating it with this HTML template file. And if we look at that, you will see that it uses Angular view syntax to display the current count property. And we've got a button that when you click it, it's going to increment this counter. Okay, so pretty straightforward stuff, and that's how that works. But we are not limited to just making Angular applications. We can also make applications with various other client-side technologies. So I just want to quickly show you the React Redux application. Anyone using React here currently? Smallish number, like 5% of people. Of you people with your hands just up, how many of you are using Redux? Almost all of you. Okay, so Redux is very common and popular among React developers. It's an application architecture. It's a way of structuring the way that data is stored, the way that state is managed in your application. It's often called a state management library. I'll give you a quick indication of how that works, but I won't really have time for a full tutorial. Let me just start up this React Redux application, and then I'll give you a quick look at what the code looks like in there. And when that pops up, you'll see that it looks almost identical to the Angular one. So we're trying to give a fairly consistent starting point there. It's got the same examples in it, same counter type thing. And if you want to see the code for that, let's have a look at that. It's quite different because it's a very different architecture. So we've got a class, again, another TypeScript class. This time it's a React component. And all it's responsible for is rendering this bit of the UI. It doesn't contain any behavior besides rendering. And it displays the current count value, and it's got a button that when you click it, it's going to raise an action called increment. This is where Redux comes into it. Redux manages the state of the application and how that state changes over time. And it stores those states in things called stores. If we have a look at the store for the counter data, you can see it's storing this count property, which is a number. And you can ignore all the other code there because it's all just boring boilerplate. The only bit that's really relevant to us is what happens when one of these increment actions occurs. We change the count to one more than it was before. So that's how the Redux store is updating its internal state, and then the counter property will the counter component will re-render, and the UI will update. But don't worry about if you're unfamiliar with Redux. It's not really central to this talk. Okay, so that gives you an indication of how we can get started with just creating file new projects. But what's the point of that? What benefits do we get from using these particular templates as opposed to if you just set this up on your own? Well, there's quite a number of non-trivial bits of functionality in there that are designed to make your development experience more fun, more productive, and generally make you happy in all possible ways that software can. So let's see the first one of those features, which is a feature called hot module replacement. And we get this from Webpack, which I'll talk about in more detail later. But let me just show you the hot module replacement feature. So what that feature does is it gives you a very quick way of seeing how your changes to the code affect your application. So it saves you a lot of time, basically. Now, these applications are all written with TypeScript, and normally TypeScript has to be compiled, and after it's compiled, you would have to reload your page in order to see your changes, and that's all boring work that just interferes with your happy flow state and prevents you from getting on with your job. So wouldn't it be nice if you didn't have to do any of that? If you just changed your code on your application was just updated immediately without even having to reload the page. So that's what the hot module replacement feature does, and I can show you that very quickly by just making a change to the application code. So you can see we've got this counter there right now. If I come in here and I change this to, let's say, super counter, then let's just move out of full screen mode, and I'm going to press the save button now. And when I do press that save button, we should see in the browser that it updates immediately. I didn't have to switch back to the browser or reload the page. And the best thing about it is it hasn't even lost the application state. You see we've still got this current count property of 3, and I can just carry on working with my application even though I'm changing the code. So it's not just the markup I can change, I can also change any aspect of the application. I could change, for example, this, so that instead of displaying the count normally, we'll display the count times 2. So when I press save on that, we should see that it changes from 4 to 8 now. Okay, that's good. Or I could even implement some entirely new functionality while my application is running. So let's say I want to have a decrement button as well. Okay, that should be pretty easy. I'm just going to copy this line for the increment button there. I'll change the text on it to decrement. Okay, and then if I change the method that it calls to decrement, then when I go back to my browser, I should be able to now make the count go down as well. So I can modify the application and add and remove functionality while it's running, and it updates very quickly without me having to manually compile anything. And it even works okay if you make a mistake. For example, if I go in here and I try to call a method that doesn't even exist, like this, then what's going to happen in the browser is it's going to say, oh, you just made a mistake there, can't find name blah. Okay, so you can come back to your code and you can just fix your application code there, save it again, and then hopefully the browser will pop back to life and our application will be back there and it's still running and it hasn't even lost the state that it had. And this ties in really well with Redux. If you're using Redux, one of the cool benefits of it is that it tracks all the different states that your application progresses through. And so let me show you a cool sort of debugging thing that you can do with that. Let's say that I've got a user who starts off here on the home page, and then they move to the counter page, and let's say they move back, and then they move back again because they're just really indecisive. And then eventually they start clicking on these buttons up and down and up and so on. Because I've used Redux, it's tracked all the different states that my application has been in. So if I use the Redux debugging tool, I can see a list of all these different states that it's moved through. And I can even use this timeline to move backwards and forwards through time to replay all the events that have taken place. So I can replay all the different states that the application has moved through. And this is retained even if I actually change my application logic. So let's say that we've just realized there's a bug. You shouldn't be allowed to move the counter past 5, but look, I've already moved it to 8, so that's a bug. I shouldn't be allowed to do that. So what I'm going to do is I'm going to change my application code. I'm going to say, okay, if the count property is less than or equal to 5, then I'm going to display that. Otherwise, I'm going to display this message, stop clicking now. Okay? So when I hit save on that, we'll see back in the browser, it's going to change to say stop clicking now, because the user has already clicked too many times. But we can even replay how it would have behaved if they were in different states. I can go back in time and see what the application would have done with the same set of user actions, but with respect to my new code. So I can check that I've effectively fixed this bug. You know, I've fixed it in a really bizarre and dumb way, but you can see that the changes I've made have taken effect, and we've still got this whole history that the user has been through. So that is pretty cool and not something that you would have normally been able to do. But that feature comes to us courtesy of Webpack's hot module replacement and Redux. OK, so that's good. Now, next feature that I want to show you, pre-rendering. This is quite a technically advanced feature, but it's again, it's a pretty cool feature, and I hope you'll find a good use for this sort of thing. Now, the best way to understand this feature, I think, is to see what happens if you don't have it. So what I'm going to do to demonstrate this to you is remove the pre-rendering from my application, show you what problems can occur, and then how they get solved by adding pre-rendering back in. So let's go back to full screen here, and I'm going to switch back to the Angular application for this demo, just so that we can keep moving and show you all the different applications. So let's close this one. Okay, so when that comes up, you'll see my application's here and it's behaving kind of normally. But I've already got the pre-rendering feature turned on by default. I want to turn it off. So I'm going to go to the Razor page that hosts my application, and I'm going to remove this tag helper. Now, I'll put it back in a minute and explain what it does, but let's just pretend that you never had that and you've never even seen it. Okay, and I'm going to reload my page and see how it behaves. So it behaves perfectly normally. It comes up and it works. Great. But every time I hit reload, can you see up in the top left, I've got this word loading. And that lasts for how long? like half a second or 1 second or something like that. And what's happening during that time is that the browser is fetching all the JavaScript from the server, it's parsing it all, it's executing it all, it's building the initial DOM structure, it's setting that as the current DOM, and finally it's painting it all to the screen. So it's doing a lot of stuff, and it's taking about, I don't know, 3/4 of a second or something. Now, you might think 3/4 of a second is okay. It's not too long for your application to spend loading, and people can afford to wait that long. But in the real world, it's probably going to take a lot longer, because this is a very artificial demo. I've got a fairly fast laptop here, and I've got an insanely fast connection to the server because it's actually running on localhost. So that's not very reflective of real-world conditions. If we want to see what it's really going to be like for our end users, let's simulate a slower network. So I'm going to simulate, let's say, a 3G network, because we want mobile users to be able to access this. And of course, mobile devices generally have slower CPUs as well. So I'm going to throttle that down by a factor of 10 to represent a fairly mid-range mobile device. And we'll see how long it takes for the application to come up now. Starting from a blank page, I'm going to start loading the application now. And we'll see how long it takes. Well, we've got the word loading. That's good. That's a start. But we're still waiting. The browser's fetching the JavaScript. It might have finished fetching it now. It might have started parsing it. It might have started executing it. I don't know. But the end user is probably, oh, finally, it's there. OK, so if your end user could be bothered to wait that long and didn't just click back, they've finally got to your application. But it took a long time. And of course, in the real world, it might be even worse still. You know, not all networks are as fast as 3G, and not all devices are as fast as whatever I just simulated. And in fact, there are even worse scenarios that could occur. Okay, the absolute worst thing that we can imagine, the nightmare that keeps us all awake at night. What happens if they didn't even have working JavaScript in their browser? What's going to happen then? Well, let's see what the user experience is like now. So I'm going to hit reload, and what am I going to get? Well, I'm going to get the word loading, and that's all I'm going to get. It's just going to stay on the screen forever. So it's lying to the user, and it's just not an optimal user experience. I think we can probably agree. But you know, what do you expect? It's a JavaScript application. It's written in Angular. Of course, it requires JavaScript to be on in the browser. You can't expect it to work otherwise, can you? Well, this is where it's useful to introduce server-side pre-rendering. So let me turn that on. OK, so I'm putting this tag helper back now. And this is saying, ASP.NET, I would like you to pre-render this JavaScript module here, this JavaScript module called main-server. And that is something that has been compiled using Webpack, and that contains all the code needed to execute the Angular application. And this means that we can now execute the Angular application on the server to produce the page as an initial HTML. We can send that initial HTML down to the browser, just like a normal, traditional server-rendered application, and it can display it immediately without having to fetch any JavaScript. And then it can load the JavaScript in the background, and then the client-side application can take over. So let's just check that works. Now, I've still got JavaScript completely disabled in my browser, but I hit reload, and what happens? My application shows up. So I still get to use my Angular application, even though I don't have JavaScript in my browser. Or kind of, anyway. It's not really designed to work without JavaScript altogether, because many things are not actually going to work. For example, if I click on this increment button, nothing is going to happen, because that's just wired up to some Angular code, which obviously can't run right now. In fact, the only thing that can work is basic loading the page and navigating. But anyway, that's not the point. The point of it is not to work when JavaScript is disabled. The point of it is to make the page initial UI come up much, much faster, because we don't have to wait for fetching the JavaScript or for parsing or executing it at all. So the normal scenario that this is designed for is the page comes up very quickly, the client-side code then loads in the background, and then that takes over execution of the page, and it becomes interactive. And if you're wondering how long that actually takes, or how long it takes to do that initial rendering of the HTML, let's load that, and we'll see. And we'll see, in this specific example, it's taken 49 milliseconds there to render the initial page on the server. And if you compare that with how long it might have taken otherwise for the browser to fetch that JavaScript and execute it and everything like that, the initial UI might not have come up for 5 or 10 seconds, but we've been able to render it there in 50 milliseconds, which is quite an improvement, I think you will agree. OK, so that is the server-side pre-rendering feature. Next thing on our list is deployment. Now, I'm not actually going to demonstrate deployment to you because it's way too boring, but I just want you to know that we do have a feature here. And the feature is making a nice compact production build. So at the moment, if we have a look, if I do a reload, you'll see this application is currently 1.4 megabytes that we're sending down to the browser, which seems like a lot, but it's okay because that's just a development build. That contains all the unminified code, all the source maps and stuff. So yeah, it's going to be massive, but you don't want to serve that to the end user in production. And that's a feature that's built into the templates. When you do an actual publish of your application, we'll produce a much more compact minified build for you as you would want. Okay, so that's that out of the way. Next thing on the list, a little bit more interesting, debugging. Now, we all love debugging, right? It's one of our favorite activities. We'd spend all day doing it if we could, and definitely we want it to be the nicest experience that we can. Now, how can you debug an application like this? Well, it's written in TypeScript, but of course, in order to execute, it needs to be converted into JavaScript. So does that mean that we have to debug the JavaScript code? No, because as I'm sure you've probably heard, there's this thing called source maps that allows browsers to show the original source code rather than the compiled code in order for you to do your debugging. And just to show you that that's all set up and working, if I go in here, let's say I want to debug my counter code, I can do a Control-O, and I'll search for the counter component, the TypeScript. And because the source maps are already set up for us, we can see the original TypeScript code there, even though the browser itself doesn't understand it. And we can do things like set breakpoints on that, and I can click on it, and the breakpoint will hit, and I can inspect my application state and everything. And you get a fairly reasonable and satisfactory debugging experience, as much as debugging ever can be satisfactory. But that's not all. Sometimes people say to us, well, you know, that's all very well, but I don't write my code in the browser. I write my code in the IDE, and I would like to do my debugging in the IDE as well. Thank you. Can I do that? Now, normally that would be quite difficult because your IDE is not the thing that's actually running the code. But it is a thing that Visual Studio can do. It can communicate with Chrome and negotiate all the source map stuff, or with other browsers as well, Edge, presumably, I don't know. Anyway, if we actually want to make this work, we don't have to do anything clever because it is already set up by default. So if I just set a breakpoint on there and I hit F5, then what's going to happen is it's going to pop up a debug instance of our application. It's going to set up a connection between Visual Studio and Chrome there. And when this comes up, it's going to do all the stuff with the source maps to negotiate between these two different representations of the application. And so now, if I come in here and I click on this increment button, we should see in Visual Studio that the breakpoint has hit. And again, I can inspect the state of my application and carry on with that. So that just works out of the box and is all very nice. So let's stop that, and we can say that we've seen, we can say that we've seen debugging. All right, last thing on our list now, writing tests. How many people write automated tests for the actual UI in the browser code? Next to nobody. Okay, fine. Now, I know that there are good reasons for writing tests for your code in the browser sometimes, and there are also good reasons for not doing it sometimes. The cost-benefit analysis is not conclusive one way or another. Whether or not it's a good idea to do depends on your exact nature of your business and how important it is and how fast you need to write your code and so on. But for people who do want to write tests, we've got that set up out of the box for you. So let me show you how that could work. Now, as an example, we'll use this counter again. And inside the project template, there's an example specification for the counter, counter.component.spec.ts. And if we look in there, you will see that this is set up to work with a testing framework called Karma. Now, Karma is the most popular of the automated testing systems for Angular, and that's what we're using here. It allows us to run our code in a real browser and make assertions about what is actually happening at the UI level rather than at a pure unit testing level. So we've got some code here that says, before we run any tests, we're going to create an instance of this counter component, and then we've got a couple of specifications. We're going to say, firstly, it's supposed to display a title, which is an H1 element with a certain bit of text inside it. And then we're also saying that the actual count element has got certain behavior. So we will get a reference to that strong element that displays the count. We'll say its initial value should be 0. And then when we click on the button here, wait for Angular to do its stuff to update. And then we should be able to see that the actual text in the browser has changed to 1. Let's run that so we can see it working. I can do that on the command line. So I'll go to my Angular application, and I'm going to run npm test, which is configured to start Karma. So Karma is going to start up, and what Karma does is it creates a real instance of an actual web browser. You can configure which browser it uses. You can have it connected to multiple browsers simultaneously if you want to test across multiple types of browser. And what it does is it uses a WebSocket connection to send your tests into the browser and get the results back out very quickly. And we can see on this occasion, it's executed those 2 tests and they both passed. That's great. But another cool thing that Karma does, which is a bit like the Webpack hot module reloading feature, is that it watches for changes to your source code, and when they happen, it's going to rerun your tests immediately. And that allows you to work in a sort of test-driven way if you want to. So let me give you an example of that. Let's add some new functionality to our application, and we'll drive that by writing some tests first. So I'm going to keep the Karma window down there at the bottom so we can keep an eye on what it's doing. And I'm going to go back into Visual Studio, and I'm going to write a little bit of extra code. Now, what functionality can we add? Well, probably the simplest and most obvious thing that we could add would be a decrement button to go next to the increment one. You'll remember that I implemented decrement for the Redux application at the start of the talk, but I haven't done it for the Angular one yet. Let's do that. But first, we're going to write a test to specify how that should work. Now, like all good developers, we're going to write our test by copying an existing test, pasting it, and then modifying the behavior, okay? So let's just put a header, test decrement, okay? Now, we don't have a decrement button yet, but let's create a variable for it, and we'll say we'll look for a button that's got a CSS class of dec on it, and then that decrement button, we're going to try and click it. And then we'll wait for Angular to do all its stuff to update, and then we should check that the text value has gone back down from 1 to 0. Okay, makes sense? I'll hit save, and then Karma will jump to life, and it will say, I've run all your tests for you. Oh, by the way, one of them's now failing. That's bad, isn't it? And you'll think, okay, why is that failing? How can I possibly have done something wrong? Let's have a look. Cannot read property click of null, okay? We are trying to click a button that does not exist, so it's quite reasonable that that didn't work. Let's add that button. I'm going to go into my view here. I'm going to go and copy and paste again, and I will change the CSS class there to dec, and I'll change the tech to decrement, and I'll make that call a method called decrement counter. Sounds like that should work, right? Let's try it. I'll hit save, and Webpack says, no, it still does not work. You have not done your job right. What have I done wrong this time? Decrement counter is not a function. Oh yeah, that does make sense because I haven't implemented this decrement count function yet. So let's do that. Yet more copy paste. We'll change that to decrement counter, and we'll do current count minus minus. I'll hit save again. And this time, yes, finally, we have successfully implemented this excellent bit of functionality. Okay, so we can even see, in fact, that the hot module reloading thing has been working in the background. If we go back to the browser, I don't even have to reload the page, but my decrement feature is already there and working for me. And we knew it was going to work, right, because we'd written a test for it, and tests don't lie. Okay, so we've checked that our application works. We've built a nice little single-page application, and we've walked through a whole load of the different features that are going to give you a good experience as a developer. But along the way, I've repeatedly been referring to Webpack as having done quite a lot of the magic for us behind the scenes. But what is Webpack? More hands, please. Who's using Webpack? Okay, that's good. That's at least a third of you. That's well up from what I'm used to. Okay, Webpack continues to gain ground. And in fact, Webpack is probably, if you look across the whole industry, easily the dominant front-end build system now. You may have used other things like Grunt or Gulp in the past. It is not like those. People often get this misconception that Webpack is just yet another thing like Grunt or Gulp, but it's not. It's different, and I'm going to explain why. Okay? And to understand how it's different, we need to start looking at how you configure Webpack and what it actually does. And at first, if you haven't seen this before, you might find it a little bit overwhelming or intimidating, but don't worry, you're not expected to understand everything. Firstly, I just want to show you a couple of key things that are going to give you some insight into what this thing is actually doing. Okay, so here's my Webpack config that we get out of the box with this template. And it's kind of scary at first because it's massive, it's 71 lines long, and you'll think, what on earth is all that stuff doing? Well, the only thing that you need to know right now are three things, okay? The first thing is that we've got an entry point. The entry point tells the Webpack compiler where to start building the application. And in this case, it's starting by building a file called bootclient.typescript. And that is the entry point to my whole application. Now, the second thing you have to understand is that we've got a list of rules. And rules tell Webpack how to process each different type of file. And so we've got rules for different types of files like TypeScript, HTML, CSS. And for each one of those, I'm configuring a loader. I'll explain what a loader is in a minute. So we've got an entry point, we've got rules, and the third thing is that we've got plugins. I've got plugins for various different things. For example, it doesn't matter what we've got. Okay, we've got various plugins, but it's not important what they are. Okay, now what is that doing? What are those three things actually doing to build our application? Okay, let me talk you through it. What Webpack does is it starts with your entry point. It finds that file, which in this particular example was a TypeScript file. Now, Webpack does not know about TypeScript natively. It doesn't know about any type of file natively, pretty much. So for each type of file, you have to have a rule to say, what am I going to do when I see a file with that particular file name extension? And you configure which type of loader it's going to use. You'll install each of the different loaders that you want to use, and that gives Webpack the ability to work with that type of file. And a loader does two main things. Firstly, the obvious thing, it tells Webpack how to compile that type of file to produce JavaScript or whatever other type of resulting file you want to be. So a TypeScript loader is obviously going to work by calling the TypeScript compiler to produce JavaScript. So that's one of the things it does. The other important thing it does is it tells Webpack how to find the relationships with other files. So in the case of TypeScript, you've probably got a reference to another TypeScript file because you've imported some other file, and that other file probably imports some other file still. And the loader tells Webpack how to explore that chain of dependencies. Now, TypeScript can also refer to other types of files. You can refer to a JavaScript file, and that JavaScript file might even be inside an NPM module. And that's how we're consuming all the different third-party libraries here. For example, Angular ships as a set of NPM modules, and our TypeScript files contain references to JavaScript files inside those modules. And then Webpack is going to use the JavaScript loader to discover the dependencies on other JavaScript files, which might be in the same NPM module, they might be in a different NPM module. It doesn't matter, but Webpack is going to explore that chain of dependencies. And so you can see from this that Webpack is not just processing all the files in a directory, but rather it's understanding the actual relationships between your files. And it's not just code as well. You might not have expected it, but you can have a reference from a TypeScript file to an HTML file. And that is the sort of thing that you're doing if you've got an Angular component which has a template file which is itself HTML. And the TypeScript loader, or the one for Angular, is going to discover the dependency on that HTML file. And then Webpack will use the HTML loader that you've configured to discover the dependencies on other types of files as well. Maybe you've got a reference to a CSS file, which it can load through the CSS loader, which might reference more CSS files, which might in turn reference some image files. And there are various different ways you can configure Webpack to process images. Okay, makes sense so far. You can even go crazy and have references to completely custom types of files that you've invented yourself. As long as you implement your own loader for it, and you tell Webpack, you give it some code that actually does the compilation, and you also give it some code that returns the dependencies on other files, for example, to some TypeScript file. You can do whatever you want. So that explains how Webpack is able to discover all the files that are actually being used by your application, and the loaders will tell it how to convert those into whatever the output format should be, such as JavaScript. But there's more to it than that, because as I showed you, there are also plugins. Now, after Webpack has built up this big dependency graph in its memory that tells it how your application is built, it's going to pass that through all of your plugins. And your plugins can do whatever they want to it. For example, you might have a minification plugin that says, anything that gets compiled to JavaScript, I can take that JavaScript and then I can minify it. And that's how you can be able to minify your TypeScript code. Even though TypeScript doesn't know about minification, and minification doesn't know about TypeScript, it doesn't matter. You just get all these things working together. And then after all the plugins have run, Webpack can actually just write out the resulting files to disk. And you can control how that works. You can control what the file names are going to be, whether everything goes in one file, whether stuff gets split out over different files or whatever. It's entirely up to you to configure that in whatever way you want. So as you can see, Webpack is a very powerful and sophisticated system, and you can use that to take whatever set of input files are in your application and produce whatever sort of output structure you want with a fairly deep understanding of how the relationships between the different files works. That doesn't undermine, it underpins various features that Webpack itself has. For example, the hot module replacement. It knows when a certain TypeScript file changes, what other things that might affect, and therefore what needs to be re-injected into the page. So it's got lots of powerful benefits like that. Okay, now that you know that, hopefully it won't be completely insane to imagine that you could extend that Webpack config to configure it to do other things as well. So let me give you an example of adding the ability to compile an additional type of file in our application that's not currently supported. Okay, so the scenario here is you've implemented this application and you're quite proud of yourself because, you know, it's a pretty impressive application, and you've delivered this amazing new piece of functionality called Counter, which you think your customers are absolutely going to go wild over, and you're going to make tons of money out of this. And you present it to your board of directors and you say, look at this awesome thing. Isn't this going to be great? We should do a massive ad campaign. It's going to be awesome. And they look at it and they say, that is a really great feature. We definitely like that and we want to ship it. But we don't really like the visual design. It doesn't look very good. It's not very snazzy. So we're going to hire this incredibly expensive designer, and they're going to come up with this astonishing design that's going to make everyone love the Counter feature even more than they otherwise would have done. So you get this designer hired, and they say, yeah, I've made this amazing design, and I'm going to send you a Sass file. And you think, Sass? Yeah, I've heard of that. It's, what's that? It's that styling thing, isn't it? It compiles to CSS or something. I'm not sure about that, but okay, they're going to send me this Sass thing, and I need to somehow make it get compiled as part of my build system. So how can I make Sass work in my application? I don't know. Let's start by just seeing what happens if we've got a Sass file in the first place. Okay, so I'm going to add a Sass file to my application. I'm going to do add new item. Visual Studio probably has special support for Sass or something. I don't know. I'm not bothered. I'm just going to create a new text file called styles.sass. Okay, and I'm going to put a design in here. Now, I did hire a very expensive designer, and they came up with this design. So they said that we should have this variable called myCol, and the value should be red. And then the design is every single thing should be myColor. Okay, so that's the design. Okay, now let's see if we can actually make that work in our application. I'm going to save that, and I want to somehow make that apply to the Counter component. So I'm going to go to my TypeScript code here, and if you know Angular, then you will know that the way to add styles is to use this style URLs property, style URLs, and I can give an array of different style files that should be applied to this component. So in this case, I want to apply styles.sass, okay? Not that, that's a mistyping, and that would not work well. Okay, so let's try that. Now, I'm going to hit save, and then I'm going to quickly switch back to the browser, and we will see what happens. Okay, it does not work. Why does it not work? Because Webpack has no idea what this Sass thing is, and it says, you may need an appropriate loader to handle this file type. Okay, fine. All right, so I need to configure a Sass loader for Webpack. How do we do that? Okay, well, in the real world, what we do is we go to Google and we type in Webpack Sass. And what Google tells us is you need to configure the Sass loader in your Webpack config. And it's very simple. It's one line. Well, firstly, you have to actually install the Sass loader. And you do that using npm. So you say npm install Sass loader like that. And then you run that. But I've already done that. So then you go back to your code and you go into your configuration here. That's not the config. This is the config. And then you say, OK, I want to do something similar to the CSS file. So let's copy and paste that. But for Sass files. So when we see Sass, what are we going to do? Well, we're going to use the Sass loader. So let's put that onto our list of loaders, Sass loader. OK. But we also still need these other loaders because Sass is only responsible for converting Sass syntax into CSS. That's all it does. It doesn't do anything else. So we still need to have the CSS loader, which is going to tell Webpack how to understand the result in CSS, how to detect its references to other files, and so on. And then finally, we've got this slightly weird thing called toString loader. And that is specific to an Angular application because Angular components want you to give the style to them in the form of a big string, not a file on disk, but a string, and that's what the toString loader is going to do for us. So hopefully, if I restart my application now to make it pick up the updated Webpack config, then when it comes up, hopefully we will not get the error that we had before, but rather we will, oh, we do get an error. Did I not save that? Let's try that again. Not sure what I did there, but let's just restart that. Hopefully, this time, when it comes up, it will not give me the error, but will rather do something sensible with the actual Sass file, okay? So my application is here, and if I go on to Counter, you should see that my amazing new design has taken effect, and Sass is actually working there. Now, the cool thing about working with Webpack is that all these different features are independent of each other, and they all work together. So if I, for example, go and change my Sass file, let's say I'll change this color here from red to green, and I'll hit save, then what we should see is that immediately it updates in the browser. So again, SAS doesn't know anything about hot module replacement, but all these different parts of Webpack just work together, so I can make changes to my code, and it's all just going to flow through immediately, and we have a nice development experience, but you can't read that, so let's change that. Okay, great. So that is how we could extend our build system by writing a bit of custom Webpack config, and I hope that wasn't looking like it was a completely insane thing to do. Okay. Now, last part of the talk, and this is for people who really want to do something a bit more advanced. If you want to get really deep down into the engine of how this stuff is working, then let me tell you about what's actually going on behind the scenes here. Because there's been quite a bit of stuff here that I haven't really explained. For example, we've been running Angular and React code on the server, which is a bit odd, isn't it? Because that's JavaScript code. How can we run that JavaScript in the middle of a .NET application? And whether or not you can guess this, it is a fact that also all of the Webpack stuff is JavaScript as well. Webpack is written in JavaScript and all the loaders are written in JavaScript, but we've been running those on the server as well. How could we possibly be running JavaScript on the server in a .NET application? Well, the way that it works is that we've got a couple of NuGet packages that make this possible for you. So these applications are referencing a NuGet package called spar services. And that contains some logic for doing some stuff that's generally useful for all different types of single-page applications that you build. For example, there's a general-purpose implementation of pre-rendering. There's the ability to do funky stuff to interact with Webpack, which I've been using in various demos so far. There's also a feature that makes client-side routing configurations work with your server-side routing. I didn't demonstrate that because it's way too boring, but it's there, and it's just good to know that that's in there. Okay? But that still doesn't explain how this stuff actually works. Well, internally, when this stuff wants to execute JavaScript code on the server, it uses yet another NuGet package, which is a more low-level package which just provides the service of being able to execute JavaScript on the server. And as for how it actually does that, well, you can guess from the name, it uses an instance of Node.js. So in the background, it's creating an invisible instance of Node.js, and it's got a very fast remote procedure call implementation that can send invocations into Node and get results out very quickly, very robustly, and it deals with all kinds of dull things that you don't want to deal with yourself, like process lifetime management and what happens if the Node process crashes and we have to recover it and all that stuff. You don't have to think about that stuff. You just use the Node services package, and then you can run JavaScript on the server in your .NET environment. Now, a couple of things about that. One is, why are we using Node and we're not using some other type of JavaScript runtime? Like, why don't we just have a standalone instance of V8 or Chakra Core or whatever? Well, the answer is that a great proportion of the third-party code that you want to use will assume that it's running inside a Node environment, and it's just not going to work for you if you don't have a real Node environment. So that's why we've done it like that. And the other thing that many of you are probably thinking is, why do I want to run JavaScript on my server? I've got C#. Are you somehow saying that C# is inadequate? Like, why can't I just write all my code in that? Well, I'm not saying that there's anything wrong with writing your whole application in C#, obviously, but there are very often cases where you will want to use third-party code which is written in JavaScript. So obviously, if you want to use Angular on the server, well, that's JavaScript. You're probably not going to implement your own C# version of Angular. And in fact, more broadly, there's the entire Node Package Manager ecosystem. So NPM is the largest collection of open source packages that exists anywhere, and everything that you can ever think of doing exists as 15 different NPM modules that's hard to pick between. But when you do pick between them and want to use it in your application, that's what this allows you to do. So let me give you an example of how we can use an arbitrary third-party NPM library in the middle of an ASP.NET application to do a cool thing that would otherwise be quite tricky to do. Okay, so let me give you a final demo of that. And for this final demo, I'm going to switch over to a different application. So let's go to my Node Services example. Let's set that as Startup Project and run that. Now, this is not a single-page application, not written with Angular or React or anything like that. It's just a regular, boring old server-side ASP.NET MVC application. It's the same thing that you get when you do a file new project. The only thing that I've changed about it is I've modified this about page to put in this little request that we've had from the marketing department that, for whatever reason, we're supposed to add a picture of something in Oslo here. Now, that doesn't sound very difficult, does it? We're all very experienced, competent, high-end web developers, so we can add images to pages. I think we can manage that. So let's have a go at doing that. We'll go into our About page, and we'll see this is where they've put that note for us. Now, we want to add an image. Now, firstly, we need to have an image of something in Oslo here. Now, I've already got one, so let me just show you that. If I go in here and look at my images, you'll see a picture of this building. It's just up the road from here. It's quite nice. If you haven't been there, there's a nice little cafe in there. It's all very lovely. Go and visit it. And I want to put that picture into this web page. Now, like I said, we're very experienced, skilled, and high-end web developers, so we know how to add images to pages. We can do an image tag, okay? Good. Now, does that actually work? Let's see. I'll come back to the page, and I'll hit reload, and we'll see if we get our Oslo picture. And, that does not look right. That's a big blue rectangle. So what's going on there? Well, if I scroll around a little bit, you will be able to see what's going on. That image is somewhat too big to fit in there. So how can we fix this? Well, a couple of ways. The most basic way is we could just put a width attribute on there, and we'll say, we'll have the browser resize that down to be 300 pixels wide. That works. But it's not a very good solution because we're still sending the massive image to the browser. And if we look at how big that is, you will see that this is a 7.9 megabyte file. That is not what we want to be sending on every single page request. We want to resize that. So how can we resize this image? Well, one way that we could do it is we could fire up paint.net or Photoshop or whatever and just resize the image. But that is boring. Like I said, we are skilled high-end web developers, so we're going to do some dynamic server-side image resizing just to show how worthy of our salary we are. So I'm going to change the way this works. Instead of referencing this file on disk, I'm going to reference a controller. I'm going to reference a controller called resize controller, which I haven't implemented yet. And then I'm going to pass it a parameter of how big I want this image to be. Give it any number I like there. Let's say 250. OK? Now, if I reload initially, that's not going to work because, like I said, I don't even have this controller yet. So the server is just returning a 404 error, as you will see. If I look at it here, HTTP 404, that's an error. OK, so let's implement some code that dynamically resizes this image. And I want to do that by creating this resize image controller. I've just got an empty file there right now. I need to put some actual behavior in there. So first I'm going to drop in a bit of code that finds the file on disk that we want to resize. And there's a little bit of stuff here, so let's just walk through it step by step. On this line here, we're telling MVC that we want it to respond to all requests that start with resize/something. And we're going to capture the rest of the URL as a parameter called image path. And then we're also going to accept another parameter, which could come from the query string, which will be the width. I'm giving it a default value, but you can override it by passing a query string. And then the next thing is we want to actually find the file on disk if it exists. So I'm using the webroot file provider, and that's a very easy and safe way of locating files that are inside the www.root directory. So I'm saying, let's find the file that corresponds to that parameter that we've been given. If it doesn't exist, we'll just return a 404. But if it does exist, I'm going to return this message. We don't really want to return a message. We actually want to return an image. But we're just building this up step by step for now. So let's see if that actually works firstly. I'll go back over there and I'll hit reload. And then instead of the 404, this time we'll get the message that says, yeah, that does actually exist as a file on disk. So now we can think about resizing it. Now, doing image manipulation in .NET Core used to be difficult to impossible. It's not too bad now because there's a couple of pretty good open source image manipulation libraries for .NET Core. And as you might have heard, the whole system.drawing API set will be coming to .NET Core soon as well. So we can do this in .NET, but the point of this is for me to show you that we can bring in arbitrary third-party NPM modules and use them to do interesting things within our application. So I want to make a call from here into some JavaScript code. And I'm going to do that by getting from the dependency injection services provider thing an instance of inode services. Node services. Okay? And when I've got that, I can use that to make calls from my .NET code into JavaScript. So I can say node services.invoke async and then just start telling it what I want to invoke. So to get started, I want to do this. I'm going to say, node services, I would like you to asynchronously invoke some code that's in this file, resizeimage.js. And I'm going to pass to you the physical path of the file to resize and also the width. And I expect you to return a string to me. And you're going to do that asynchronously, so I have to await that. And since this is an async method, I need to mark this as async to make the compiler happy. And then I also need to say that it's going to return a task to represent that. So that's just a bit of basic MVC coding there. So now, if I run that, it will try and make a code into JavaScript. Does it actually work? Let's see. The answer is no, it does not work, because this file that we're trying to call resizeimage.js does not exist, cannot find module. Okay, so we better create that file. So I'm going to add a new file, add new item, JavaScript file, and it's going to be called resizeimage.js. Okay, and now I can put some arbitrary JavaScript in there. And just to get us started, let's return a hello world message. From this file here, I'm exporting this module, exporting this function, which takes a callback. And all I'm going to do is create this message string here, and then I'm going to use the callback to send that message back to ASP.NET MVC. And I'm saying there's no errors, you just got a message, and it's this string. So if we come back here and reload again, then this time it should find the file on disk, and now we're invoking the JavaScript code directly from the middle of our MVC action. And I can hit reload, and it's going to update and do what you expect it to do. Okay, that's good. So now we can write arbitrary JavaScript in there. And since this JavaScript runs in a real node environment, we can even pull in arbitrary NPM modules. For example, I can do some image resizing using a third-party library called Sharp. Sharp is a pretty popular library in Node world. It's very fast, it's very robust, and it allows you to do lots of interesting image manipulation stuff, and it's got quite a nice API as well. What I'm doing with it in this particular case is I'm saying, okay, Sharp, I want you to load the image that's at this physical path, resize it to the maximum, to this width that I'm passing in here as max width, and then I want to pipe the resulting data back as a binary stream into .NET. So I don't have to save it to disk. I can just send a binary stream back into my ASP.NET part of my application. And then back in the .NET side, I can say, well, we're not getting a string anymore. We're now getting a stream. And we want to return that stream to the browser. So I need to use this file result, and I'll send that result stream. And I need to also tell the browser what the binary data represents. And in this case, it's an image JPEG. OK. So finally, if I come over here and I hit reload, then instead of that message, it should actually call Sharp, and it should do the image resizing. It took a moment to come up the first time, but if I hit reload, you'll see it just happens basically instantly, because this is it's fast. Okay, so that did in fact resize the image. And if I go back over here and I hit reload, then we should see that instead of the 404 thing, we now actually get our image. And to prove that it really is smaller than before, in case you don't believe me, we'll just have a look, and you'll see it's dropped down by a factor of 1,000, which is rather a good improvement on our page weight. Okay, so what was the point of that? Well, my point is not particularly to say that you should be using Sharp to do image resizing or anything like that. My point is just to say that you can, without too much friction, bring in arbitrary third-party NPM modules and use them in the middle of your application if you've got any reason to do that. And that is a thing that underpins many of the other cool things that I've shown you, such as being able to use Angular and React on the server. So that is all we have time to do in this talk. As a very quick summary, we started off by looking at these project templates, which you can get today from on .NET New and Yeoman. And like I said, they're going to be in Visual Studio in the box when you get the next version, ASP.NET Core. And for those of you who want to go a little bit deeper, there are various packages available on NuGet and an NPM that give you access to the underlying technologies there in case you want to do some cool and advanced thing with it on your own. So that brings us to the end. If you want to learn more about this stuff, you can go to this repo on GitHub there. That's where all the code is. It's where we actually build all the underlying framework stuff and all the templates. They're all there. So you can see that. There's lots of documentation there as well. And last two things. One is, please remember to evaluate this session on the way out. And secondly, if you want to see some more cool stuff that's going on in the world of web, I've got another talk tomorrow, first thing after lunch, and we'll just do loads of cool demos of things that you probably didn't even realize you could do in a web application. So that's all we got time for. I hope you have a really good rest of your conference, and I will hopefully get a chance to chat with you over the next couple of days. Thank you.